So the next topic is high availability. It is the ability of a system to operate continuously without failing for a designated period of time. HA, here we are referring to high availability, helps in the elimination of single point of failure and enable applications continue to operate even if one of the IT components such as a server fails. So why do we need high availability? So the primary goal of high availability is to ensure system uptime even in the event of a failure. What is a failure? So other day we were discussing about the war happening between two countries. So when the data centers are there in these locations, one of the availability zone or the data center may go down. So what if your precious data or your web server is hosted in that particular location? The user should be still able to access your website, right? So that is why what we do, we will have our website hosted on multiple EC2 instances, and the incoming traffic will be diverted to these healthy systems. If one of the virtual machine goes down for whatever is the reason, so the next request, the next users who are trying to log into the web page will be diverted to the healthy virtual machines. That is what all about the high availability. So the next reason is redundancy. On the other hand, it is used for additional software or hardware to be used as backup in the event of the main software or the hardware fails. In our today's lab exercise, we'll explore this. We'll create multiple virtual machines having the same web page, and we'll try to down one of the virtual machine and check what happens. All right. So what are the types of high availability feature or option available with Amazon? So to begin with, we have one such facility called load balancing. And next, high availability can be achieved with the DNS, that is domain name server or system, that will target multiple zones. That means you will have your virtual machines in multiple zones and make the web server available in all these locations. So thereby the users who are logging in will be allowed to fetch the web pages from different locations. Same time, if there are more number of users, if there is too much of workload on a particular server, same time, even during that time, we can divert the user. Say you take the example of Flipkart or Amazon. So during the festival season, they offer $1 million sale, something like that, right? So what happens, there will be tens and thousands of users, they log in at the same point of time. The server which is providing the services will not be able to support all the users at a go. Maybe 500 to 1,000 users will be able to cater by one particular server. So what happens to the remaining people? So these remaining customers or the users will be diverted to other web servers that has the same web page, web content. So as a user, you will not be knowing which particular server you got connected. At the end of the day, your need will be fulfilled. So similarly, we have one more high availability achieving can be done through connection redirection. This will be done at the service provider or the ISP service provider level. Further, we have IP failover or targeting via dynamic routing. This happens through the network device called router with the help of routing protocol. We will take the first topic, the load balancing. In AWS, the load balancer is referred to as ELB, Elastic Load Balancer. The load balancer concept is there in networking as well as with all the cloud service providers. In Amazon, in AWS cloud environment, they call it Elastic Load Balancer. They want to be having a unique identification name. So here they call it as Elastic Load Balancer. So it automatically distributes incoming application traffic across multiple targets and virtual appliances in one or more availability zones. So the load balancer also monitors the health of its registered targets and ensures that it routes traffic only to those healthy targets. What does that mean? If there are 4 or 5 virtual machines grouped together in a particular load balancer, elastic load balancer, the incoming traffic will be keep shuttling between these 3 or 4 virtual machines only. If one of the virtual machine gets disconnected or is down for whatever is the reason, the traffic will not be routed to that particular server, to that particular virtual machine. If it happens, what will be the outcome? The outcome is the end user will see, will get a message on the screen on his browser that virtual machine is not accessible, web page not available, correct? So to overcome that, there will be a monitoring system. This health monitoring system will be keep checking the status of the virtual machine, whether that virtual machine is up and running or not. For whatever is the reason, if that virtual machine is down, not accessible, network traffic, the web traffic will not be diverted to that particular virtual machine. So elastic load balancing supports 3 types of load balancers. So user can select appropriate load balancer based on the application they are using. What is the purpose? Based on the purpose, the need can be fulfilled. One such load balancer is called application load balancer. We have next one, network load balancer. And the last one is gateway load balancer. Till a couple of months ago, there was another type of load balancer, which was called the classic load balancer, which is a very old type. Now it is decommissioned, no longer available, but still for information's sake, this information is this piece of information is added. So gateway load balancer is the latest load balancer that replaced classic load balancer. Amazon removed this classic load balancer. In place of that, gateway load balancer is operational. Let us try to touch upon these individual topics. What is an application load balancer, network, and a gateway load balancer? So far so good. Any doubts, clarification?
No, sir.
All right. So what is an application load balancer? So we call it in short ALB. That is application load balancer redirects an incoming request from one URL to another URL. So an application load balancer makes routing decisions at the application layer, that is HTTP or HTTPS. So it supports path-based routing and can route requests to one or more healthy working EC2 instances. So an application load balancer performs the following functions. What are they? It distributes client request or network load efficiently across multiple servers. It ensures high availability and reliability by sending a request only to the servers that are online. Provides the flexibility to add or subtract servers as demand dictates. So this type of traffic we can see with Amazon or Flipkart, any of the web servers. So in this pictorial presentation, you can see these are all the users who are connected to internet, and they are trying to access a particular website through the internet, www.google.com. They will type something like that. Okay, so all these users, they are trying to use the same web server. They want to access it. So what happens? All the users, they got connected to the internet, and here their network traffic goes through the internet to this web server, that is www.google.com or reddit.com, yahoo.com, whatever. So in this server, we have created a software-based or hardware-based load balancer. Okay, either of them we can use. So in our case, in our lab exercise, we'll be using a software-based load balancer. So this load balancer is always monitoring. Here in this example, we have two virtual machines in the group, in the load balancer group. These are called targeted systems. So both of them are functioning. So all these three users, the first user comes here to the internet, then hits the load balancer. Load balancer looks into the system. Okay, the system A is working, the traffic is routed. The first user goes to system A, the web server A. The second user comes and load balancer it takes, then it will check whether to send it for A or B. It will notice that server A is already catering one user, then let me send the user to server B. So the next comes the third user who is also willing to check the same web server. Once again, the traffic comes to the load balancer. Load balancer will see A and B, both of them, they are occupied, they have taken, they are supporting one user same time. And now once again, it will send the traffic to server A. So here, this server A and server B may be having 500 users to support at a time. So what happens if both of them are supporting supporting 500 users? There is another user comes here. This is the maybe 1001 or 1000 second user. At that time, we can add another layer on this application load balancer to create additional server resource, like another server number 3 will come into picture. Okay, if that limit also over, another server will come into picture. So these things happens automatically, so that we can enable that feature. We can set the target up to how many servers it should be created. Okay, what should be the minimum threshold? Minimum 10 computers, 10 servers should be always up and running. If 10 servers, if the 10 server is getting more load and other servers not able to provide the support, take that load, another new server will be created. And same time, if the traffic is low, the excess of virtual machines that are created will be decommissioned. It will be deleted. So this is all about the application load balancer. So the next load balancer is network load balancer. The way we replicated the lab exercise of application load balancer, the same thing can be performed here also. But here it will be a little bit deviation. We will not be using the HTTP or HTTPS request. Instead, we will be providing the TCP IP, that is the IP address of those virtual machines, so that the registered target will have the direct IP address. So depending upon the network traffic for that particular web server, the traffic gets routed between multiple available targets, that is virtual machines. So what is all about a network load balancer? A network load balancer distributes end user traffic across multiple cloud resources to ensure low latency and high delivery for applications. So when a target virtual machine becomes slow or unavailable, the network load balancer routes traffic to another targeted virtual machine in the cloud. So the NLB makes routing decisions at the transport layer, that is TCP, IP, or SSL, that is secure socket layer. So it can handle millions of requests per second. So once the load balancer receives a connection, it selects a target from the target group where to forward that particular request. So in our pictorial presentation, you can see here is the users, the number of users. They are trying to access a web server, which is behind this network load balancer. So the user's request hits the network load balancer. This network load balancer will check for the number of available virtual machines. Okay, so here we have VM1, VM2, maybe you can have a number of VMs. This particular request is going on port number 80. In another case, it is going on port number 8080. So finally, the network load balancer will manage the traffic. So apart from managing the traffic, this network load balancer is also keep monitoring the healthy status of these virtual machines. Which virtual machine is having more workload, it is working slow, or it is completely out. It is stopped or not accessible. So based on that, the network traffic gets routed among the healthy virtual machines. This is the another type of load balancer that is available. The third category is gateway load balancer. So a gateway is the one that sits between different networks or applications. So it converts information, data, or other communication from one protocol to another protocol. So when you say different network, maybe you have on-premises data center and a data center in the cloud. Instead of the virtual machines here, you're diverting the traffic between either on-premises and the cloud. So based on the request, based on the requirement, that particular user will be diverted to the on-premises data center or the cloud one. So that is managed by the gateway load balancer. So the gateway load balancer takes a request from clients and distributes them across targets in a target group, such as EC2 instances. So this gateway load balancer service is designed to create, scale, and manage third-party virtual appliances like firewall, intrusion detection, etc. So a gateway load balancer listens for all the IP packets across all the ports and forwards that traffic to a particular target group that are specified in the listener rule. This particular lab exercise will not be able to replicate because of non-availability of the resources. However, with the pictorial presentation, you can see the user here is trying to access, okay, his network traffic is routed through the gateway. The gateway load balancer will further divert that network traffic to which particular location, or whether that traffic has to pass through a firewall or allow that traffic directly to access the document or any feed available, or allow that traffic to pass through a security system where the user has to provide the username and password, further take the access. So that is how a gateway load balancer works. The last category is the classic load balancer. This particular load balancer is already decommissioned and no longer exists. Okay, so a classic load balancer distributes incoming application traffic across multiple EC2 instances in multiple availability zones. This is how it was designed to perform. So you can add, remove instances from load balancer as your needs changes without disrupting the overall flow of requests to your applications. So the same job performance is taken care by the gateway load balancer now. So instead of having the duplication, this has been retired, and we only have the three load balancers: ALB, that is the application load balancer, network load balancer, and gateway load balancer. With this, we'll be completing the theoretical part of today's class. Let's move on to the next topic.